Okay, next morning, I am also wearing blue. So, hope everyone is well, and the Muslims, I hope sudah buka puasa and sudah kenyang. Okay. Okay, so before we go on the topic of the benefits of glutathione for autism, go beyond inflammation, we need to revise on what is glutathione. This is the molecule of glutathione made of 3 amino acids. So it is a tripeptide, and that's glutamic acid, glycine, and cysteine in the middle. Okay, cysteine is with the sulfur and hydrogen component at the top there, which is the sulfur hydride group that gives glutathione its versatility and gives it many functions. Okay, a small tripeptide made of 3 amino acids, glutamic acid, cysteine, and glycine. It is the body's most abundant endogenous antioxidant, meaning it's produced in the body, protecting it from free radical damage and oxidative stress. And what we mean by oxidative stress is when there is excess of free radicals over the available antioxidants, and regulating its immune function. It is the most important intracellular antioxidant. So it's most important for the cell, must be most important for the organ, must be the most important for the body. It has several other major functions, plus hundreds of minor functions, from DNA synthesis to nitric oxide production to regulating the release of oxygen from red blood cells. Because of these many functions, glutathione is essential for life, and low levels are associated with many chronic diseases, and high levels are predictive of good health and longer lifespans. These are the 5 major functions that are listed, and the list, keeps getting longer. It all started with just one. It is the most important antioxidant for all cells, including brain cells. And then when the medical science moved to inflammation, it turned out that glutathione is one of the most powerful anti-inflammatory agents. Then look into immunity. It is a very important immune booster modulator, and also very important in the reversal of autoimmunity. You look at detoxification, is a very powerful detoxifier. In fact, the liver and the kidney and other organs use glutathione as its main detoxifier. And now the science of signaling molecule is coming into the picture, and glutathione is a very important and versatile signaling molecule. So plus hundreds of other functions. Now can read. During puasa time, cannot read. Okay. Now I need to explain about the difference between GSH, which is the active or reduced form of glutathione, and GSSG, which is the oxidized form of glutathione, so that later on in the future the slides, you understand what I mean by GSH and GSSG. So GSH is the reduced or active form of glutathione. So when glutathione has done its work as an antioxidant, then like all antioxidants, they all become free radicals themselves. But for glutathione, immediately 2 molecules of the GS, so GSH is the reduced form, then in the process of fighting a free radical, then it will lose the hydrogen atom, then become GS. So 2 molecules of GS back to back is GSSG, and is the oxidized form. So in that way, by combining the 2 together, then it is not reactive. Like if GS alone is reactive, meaning it is unstable. Free radicals are unstable molecules. So when an antioxidant has done its work by donating an electron, then it also becomes unstable and has to be rescued by a stronger antioxidant. But with glutathione, since it is already at the top of the antioxidant cascade, so it has to have a system that it rescues itself. So all that needs to be done is 2 molecules of oxidized glutathione combined together, then it becomes stable. So after neutralizing a free radical, GSH becomes unstable GS, which then combines with another GS to form stable GSSG. GSSG is then reactivated to 2 molecules of GSH by the enzyme glutathione reductase. So this is, the body has a mechanism to regenerate GSH. So that's why the glutathione system is the one that rescues the other antioxidants inside the cells. The important part is this: the ratio of GSH to GSSG at any one time in your cells is a critical indicator of cellular health, right? And studies have shown that it's also an indicator of overall health and of longevity, meaning if any one time your GSH GSSG level is low, you're not expected to live long. That's how critical it is. And the healthy ratio is more than 99:1. That means that at all times, there's a lot more of the reduced active glutathione ready to rescue, to fight the free radicals and rescue the cells. If it's lower than that, that means you're not healthy already. Okay. As mentioned earlier on, glutathione helps recycle and conserve other antioxidants. Glutathione's role as a reducing agent helps maintain vitamin C and E. Vitamin C protects the water-soluble components inside the cell and also relieves the body of excess free radicals by being excreted in the urine, right? So vitamin C, after being oxidized, right, 2 things can happen. It can be rescued by stronger antioxidants, or if it's not rescued, then the body just gets rid of it in the urine. So after becoming oxidized by free radicals, the non-recycled vitamin C is excreted. So people say, when you take a lot of vitamin C, now your urine is expensive. You all have heard that term, and people say, don't waste your money on vitamin C. Right? Those who say that mean they don't understand the science. You want your urine to be full of vitamin C. That means it has rescuing you, getting rid of the free radicals from the body. Vitamin E reduces the damage to the cell membrane and is used in autism treatment to support motor planning, which is needed for optimal language, social, cognitive, and motor skill. Motor planning is how your brain works. Before you do any action, your brain actually already does a lot of planning, right? You want to walk from here to there. The brain has to plan what step to take, because otherwise you might lose balance, you might not on this. So all that requires a lot of brain action, and the stable membranes of the nerve cells are important, and vitamin C helps that. Okay, this is to show inside the cells. These are the 5 compulsory antioxidants that the cells. They are called the network antioxidants. So you can see I mentioned that glutathione helps recycles vitamin C and E. But there are 2 others, coenzyme Q10 and lipoic acid, that also are recycled by glutathione, which is the master of them all. Okay, now we move to autism. Patients with autism or ASD, autism spectrum disorders, especially in the context of the brain and the cellular damage caused by oxidative stress and inflammation, may contribute to ASD symptoms. This may in part be attributable to the fact that production of glutathione is typically either impaired or otherwise inefficient in patients with the ASD. Okay, so it is known that those patients with autism or ASD, they have high levels of oxidative stress and inflammation. Okay, so when they have high levels of oxidative stress and inflammation, the implication is there must be low levels of glutathione, because otherwise, if sufficient glutathione, there won't be high oxidative stress inflammation, because glutathione can fight both. Okay, and further studies have shown that in many of them, the low level of glutathione is because of impaired production. Right? We all produce glutathione, and in ASD patients, It's found that glutathione production is either impaired or inefficient. In fact, some studies show that many autistic patients have defective genes related to one or more enzymes of the glutathione system. Okay, so that means they have problems producing healthy levels of glutathione. We have always said that glutathione production is normally adequate until about age 20, then after that, as part of aging, it goes down. But in those with defective genes or other problems that impair the glutathione production, then that statement is not true anymore, right? Even though they are young, even though they are children, they are already deficient in glutathione. So a study published in 2012, that's 13 years ago, found that glutathione levels in the cerebellum, okay, that's the hindbrain, of patients with ASD were 44.6% lower than in healthy controls. So that's a lot. And these are young children. Researchers found that lower levels of glutathione are correlated to higher levels of inflammation and neuronal dysfunction. So not only they have low levels, but the researchers found that the lower the level, the worse are the worse level of inflammation and nerve dysfunction. In samples of brain matter taken from deceased patients, that is in the autopsies, for example, patients with ASD exhibited 72% higher concentrations of biomarker molecules which signify oxidative stress-based DNA damage. That's a mouthful. It means, right, very high level of DNA damage when they were alive. Yeah, caused by oxidative stress. Okay, so this is the study, right? And this is the conclusion. Okay, so after meta-analysis, the ASD patients should decrease blood levels of reduced glutathione, glutathione peroxidase, methionine, and cysteine, and increase concentrations of oxidized glutathione relative to controls. Whereas superoxide dismutase, another of the primary antioxidants, homocysteine and cysteine showed no association with ASD. So, the glutathione system is not the only antioxidant system. There are other antioxidant systems. But this study shows that in the autistic or ASD patients, only the glutathione system is affected, right? Superoxide dismutase, you all know, you are all familiar with SOD, right? It is supposed to be the strongest antioxidant enzyme, but it's not affected. Okay, but it is the glutathione system that's affected. Glutathione in the blood reduced. Glutathione enzyme peroxidase reduced. Methionine, cysteine is a precursor of glutathione, and methionine in the body also can convert methionine to cysteine as a source. So all these are reduced. Okay. Then another study, brain region-specific glutathione redox imbalance in autism. Conclusion: glutathione is a major endogenous antioxidant that plays a crucial role in protecting cells from exogenous and endogenous free radicals and toxins, particularly in the central nervous system. The present study examines the concentrations of glutathione, right, the GSS and GSSG, and the redox ratio of GSH to GSSG, as explained earlier on, in different regions of brains from autistic subjects and age-matched control subjects. And what they found was that in the cerebellum and the temporal cortex, the temporal cortex is here, cerebellum is the back, from subjects with autism, glutathione levels were significantly decreased by 34.2 and 44.6% respectively, and a concomitant increase in the levels of GSSG, right, the oxidized glutathione, by 38.2 and 45.5% respectively as compared to control groups. And those numbers are significant. I mean, you are 45% more oxidized glutathione, and you are 44.6% less glutathione. That's significant. In contrast, there was no significant change in glutathione, GSSG, and trans-GSH levels in the frontal, parietal, and occipital cortices in autism versus control group. Okay, so mainly, those is this area, the cerebellum and the temporal. Oh, sorry, not trans, that's total GSH, yeah? Because you have the reduced form and the oxidized form, you combine the two is total. Conclusion. The redox ratio GSH to GSSG was also significantly decreased by 52.8%. So that's significant. Remember I told you the ratio must be 99:1 or higher. Close to 100, close to 100% GSH. Very little GSSG is healthy. Okay, and even worse in the temporal cortex of subjects with autism, suggesting glutathione redox imbalance in the brain of individuals with autism. These findings indicate that autism is associated with deficits in glutathione antioxidant defense in selective regions of the brain, that is cerebellum and temporal cortex. Okay, autism is also associated with autoimmunity and the lack of immunoglobulins, which cause neural inflammation that correlates with the severity of symptoms. So just now we are just talking mainly about antioxidants, okay, and the redox balance and oxidative stress. Now, on the issue of immunity and autoimmunity, also glutathione plays a central role. Glutathione can improve autoimmunity, and this aspect may explain the improvement of symptoms beyond the antioxidant and anti-inflammatory actions. Toxicity is another well-known risk factor for autism. Okay, and glutathione is the body's main detoxification agent used by the liver, kidneys, and all organs to neutralize various toxins and contaminants, especially heavy metals. So you can see, in fact, all the 5 major functions of glutathione are all applicable in autism. Yeah? Antioxidant and fighting and free radicals and oxidative stress, fighting inflammation, improving immunity and fighting autoimmunity, detox. Okay, and I've added the 5 signaling molecules. You'll find the best. I mean, when you a simple way to describe someone with autism, you can also say that there is a short circuit somewhere. Right, all right, and the short circuit has got to do with signals. It's signals. So then, right, and glutathione is a very important signaling molecule. Okay. Glutathione is important in the biomedical treatment of autism for these main reasons. Glutathione acts as the body's master antioxidant. Glutathione plays an important role in preventing and reducing inflammation. Glutathione plays a central role in detoxification of harmful substances. Glutathione regulates immunity and autoimmunity that I mentioned also just now as a signaling molecule. But there's one extra function which is helpful in autism treatment, is in managing the level of glutamate. Remember, glutamic acid, the amino acid, is one precursor of glutathione. But it so happens in the brain, excess glutamic acid or the salt form glutamate is harmful. Okay, so glutathione, by the manufacture of glutathione by consuming glutamic acid to make glutathione, which is then beneficial for the autistic person, is helps in win plus win situation. To produce glutathione, you reduce the harmful part because glutamate can be harmful to the excess glutamate can be harmful to the brain. Okay, now we come to the topic is, it goes beyond inflammation. So we know oxidative stress causes inflammation. Then just now we thought there are other issues, autoimmunity, etc. Now I want to introduce this term, cell danger response. So this is relatively new in medicine. Research has identified that in autism, glutathione status is, in fact, I would say very important. In some cases, glutathione is 80% depleted, resulting in higher levels of oxidative stress, which is excess harmful free radicals over antioxidants. And glutathione is the main antioxidant against free radicals, which we all know by now. Now, excess free radicals damage the cell membranes and intracellular components, example, mitochondria, causing impairment in energy production. Okay, so when you go into details, we just say that, okay, oxidative stress, inflammation, but you go into more detail, what is the harm, what is the damage? The main damage is in the mitochondria, which produces energy. Okay, so without sufficient energy, the cell cannot function. And if the cell is the brain cell, then it's difficult to function. So oxidative stress leads to inflammation that triggers this cell danger response. So the cell now go into panic mode, well, even animals, whatever. When the conditions are tough, you go into survival mode. Okay, but you slow down. They go to hibernation. They slow down. Okay, so the same thing. Because if things go on as normal, then the oxidative stress and the inflammation will continue, and the cell might die. Okay, so as a response to protect itself, then it goes into what is called the cell danger response. Then it goes into almost like semi-hibernation, which means now the energy production is slowed down. But with slowed down energy production, susah mau function, right? Difficult to function. Now, it's interesting, this subject. Then you start to realize why autistic children characteristically don't have eye contact, right? And you know, not just eye contact, personal interaction also difficult. But they can walk. Yeah, they can do other things, but it's the interpersonal thing. Because the brain consumes a lot of energy. And 40% of that energy is consumed by just processing visual input. 40%. Wow. Okay. So, you know, I'm just going through all this, you know, make me think also. I close my eyes, right? Suppose I'm blind, all right, and I have to rely on my hearing, all right? Yeah, I'm very, very much more handicapped than somebody who's deaf but eyes open. You see the difference? Yeah. Yeah, right? Meaning if you're given a choice, okay, either you're deaf or you're blind, better choose to be deaf. Yeah. I understand that? Because there's so many things you can do. I mean, you can almost manage now. Right? Okay, because even if we talk also, okay, I cannot hear. Okay, something come out here, I can just read what you say. Without this, you are quite lost. So 40%. So when the energy production is impaired, so the brain cells, so the most complicated part will be the one suffering first. All right? So, I mean, they can see, but they cannot process. They cannot process, that's why. That's why they have difficulty. Very interesting. So what is the cell danger response? This cell danger response is an evolutionary metabolic response to threat. It occurs when cells are damaged by chemicals, physical or biological threats. It focuses on conserving resources to protect the cell from harm, but it has disadvantages too. So once the threat is nullified, the CDR should turn off and the cells take steps to reverse the effects of CDR to revert to normal healthy function. The problem is if that whatever causes it, for example, oxidative stress, inflammation, is continuous. It's just like in life, as we talk about, in other situations, we talk about chronic inflammation. Yeah, inflammation alone is everybody can have. It's chronic inflammation that is harmful. Same thing, chronic oxidative stress and chronic inflammation causes chronic CDR. So the CDR serves to protect, but if chronic, it causes damage. Chronic CDR can disrupt the function of every cell in the body. As a result, the microbiome changes. So the bacterial component of their gut changes. The mitochondria produces less ATP, therefore they have less energy to function, and detox capacity also becomes impaired. All this require energy. So all this also happen to be the key features for the medical aspects of autism. So that we need to understand. Yeah. So how the lack of glutathione causes oxidative stress, inflammation, autoimmunity, and the cell respond with CDR, and it's chronic problems. So it is chronic CDR, and then all these things happen, and then they become autistic. One key feature of the CDR that is particularly impactful in autism is the stiffening of the cell membrane. Okay, membrane fluidity is essential for optimal development. Glutathione may improve many of the harmful effects of long-term CDR, because from what we see, it is the lack of glutathione that is the starting point anyway. And it is not just the lack of antioxidants per se, because the other antioxidants are not affected. Glutathione protects mitochondria. Mitochondria are the energy production factories in our cells, except for red blood cells, which do not have mitochondria. Energy is needed for health, growth, and development. And mitochondria come from our mothers, and they have their own DNA. During reproduction, the sperm only contributes genetic material. Half the genes and everything else are contributed by the egg cell from the mother. All right? So men only that much important. Improving mitochondrial function improves autism symptoms. So improving mitochondrial function has been shown to improve language, social cognitive skills for children with autism, with resulting reduction in behaviors like head banging and aggression. So in line, so the theory seems to work, right? The meaning, okay, if the problem now we zoom in, it is mainly in the mitochondria energy production. The proof is then if you improve the function, improve. Behavior improve? Yes, behavior improve. Anything that depletes glutathione or damages the cell membrane can impair mitochondrial function, including toxins, harmful microbes like Lyme, Clostridia, and yeast overgrowth, nutrient deficiencies, and stress. Damaged cells and cell membranes result in CDR in the mitochondria, which disrupts cell function. Stopping the CDR depends on improving glutathione status. And when CDR stops, autistic behaviors improve. Okay, but that's not all. Then we mentioned earlier on, part of the problem, also the gut microbiome also becomes affected. So gut microbiome, gut-brain axis, and glutathione and ASD. So gut microbiome is known to influence the brain through the gut-brain axis. ASD is associated with abnormal brain function. ASD is associated with unhealthy gut microbiome. ASD can be improved by healthier gut microbiome. Okay, that is what is known now. Then glutathione improves gut microbiome and overall gut health. Glutathione also protects gut wall against leakage, and gut microbiome modulates local glutathione production. So it's it's a circle. So glutathione helps improve gut microbiome. Microbiome also modulates the glutathione production there. The lining of the intestines, right, produces glutathione as its main line of defense. Children with ASD experience constipation, diarrhea, and other digestive problems more often than healthy children. And a microbiome-friendly diet is important in the management of ASD. Okay, so that's about microbiome. This experiment is very, very interesting. Human gut microbiota from autism spectrum disorder promote behavioral symptoms in mice. Okay, They take from the mice became autistic. So what other proof you want to see? Okay, so gut microbiota from human donors with ASD transplanted into germ-free mice induced hallmark autistic behavior in the mice. Okay, so you really need to concentrate also on improving the microbiome in autistic children. The treatment of an ASD mouse model with specific microbial metabolites improves behavioral abnormalities and modulates neuronal excitability in the brain. So one is the transplant microbiota from the human ASD in germ-free mice. They develop autistic behavior, and then the mouse with ASD, right, and now given metabolites from healthy. Right, from healthy microbiome, then the behavior improve. Okay, so these are some studies on the gut microbiome and ASD. Microbiota transfer therapy alters gut ecosystem and improves gastrointestinal and autism symptoms. Then microbiota gut-brain axis and its potential therapeutic role in autism spectrum disorder. Distinct fecal and plasma metabolites in children with autism spectrum disorders, and their modulation after microbiota transfer therapy. That's mentioned earlier on. Emerging roles for the gut microbiome in autism spectrum disorder, the brain-gut microbiome system, pathways, implication for autism spectrum disorder. So I do not know how much the people here treating autism are focusing on improving the microbiome. Okay. So now back to glutathione. So even from microbiome, glutathione has a big role to play. Yeah. So boosting glutathione levels via supplementation could be an effective way of supporting the body's fight against oxidative stress and inflammation and reduce the risk of damage to critical brain tissues. After boosting glutathione, studies show patients may experience fewer neurological and behavioral symptoms such as executive dysfunction, emotional dysregulation, and social withdrawal. Epilepsy is reduced and the side effects of the drugs are also reduced. Boosting glutathione in the treatment of autism helps to reduce oxidative stress, inflammation, and CDR, leading to improved sensory integration and reduction in self-injurious, repetitive, and aggressive disorders. And we can add two more things, right? Reduce the autoimmune component and improve microbiome. Right, yeah? Boosting glutathione also protects the mitochondria from oxidative stress, inflammation, CDR. That means now you can improve the energy production, which helps restore brain function and reduce abnormal behavior. Boosting glutathione improves gut microbiome and promotes healthy gut-brain axis, which is another important requirement on normal brain function. So you can see many, many ways glutathione can help in autism. Okay, this is some of the studies. The study was on N-acetylcysteine, which is well, it is the most researched glutathione precursor. Only thing is, our product is 300% more efficient than NAC. But we take this, the studies on NAC, it's still valuable information. So what they did was 33 children were randomized in two groups. One group consumed incremental doses of NAC for 12 weeks. The other group took placebo for the same amount of time. At the end of the trial, the kids who consumed the glutathione precursor had a reduction in irritability caused by 80%. Right? So this is a scientific study, not a blind. Okay, so these are some of the things reported by boosting glutathione levels. Epilepsy is reduced, anxiety is reduced, depression is reduced, and reaction to medicine is also reduced. Though there are no large studies, there are no large clinical trials investigating glutathione as a treatment for ASD have been completed thus far, ample research have established the link between oxidative stress, inflammation, and ASD symptoms, such that glutathione supplementation has become the most likely prospective therapy, especially since it can be done conveniently and cheaply compared to other novel therapies. The best way to boost glutathione is by taking glutathione precursors, because glutathione itself is poorly absorbed. Okay, so here comes the role of ribosine, which is not just another glutathione precursor, but it has stabilized cysteine, which will enable the cell to produce glutathione. And it has ribose, which will increase the ATP, which is not only required for the production of glutathione, but now we know it's especially important in autism, right? Because the problem is in their mitochondria. Glutathione protects mitochondria, therefore enhancing ATP production. And ATP powers GSSG synthesis, boosting the production. Right now, we know ATP also is a problem in ASD. So no wonder ribosine is 300% better than the next best glutathione precursor, NAC. And since glutathione protects mitochondria, no wonder it can protect us from brain disorders and many diseases and aging. And this is the studies that show that ribosine is 300% more effective in boosting glutathione than NAC. And our product next one is 100% ribosine, and Celgevity is ribosine plus 12 other ingredients with many other benefits, and that it can be called an anti-aging powerhouse. Thank you.